Hello guys, today I am going to explain about our major project, performance analysis of real and complex wavelet transform using wavelet based image denoising. What is noise? Noise in digital images refers to random variations in the brightness or color of individual pixels that can degrade the overall quality and clarity of an image. So image denoising is used to remove the noise. Image denoising is a principal technique majorly used for restoration, segmentation and image classification of original image. It is used for refining of images by eliminating the extra noise. Denoising is done using the wavelet domain filtering technique. These are our project objectives. First one, to understand the concept of noise in images from the existing literature and build a problem statement from the proposed wavelet based image denoising. To implement basic filtering techniques to noisy images, to apply various wavelet based techniques to MRI images with soft thresholding, to implement base shrink adaptive thresholding mechanism to noisy images with dual tree complex wavelet transform, compare the proposed method with deep learning based models, and also the performance comparison of all techniques using the metrics PSNR and RMSE. So in various denoising techniques, wavelet based filtering is one of the technique which is used to decompose image coefficients into frequency components and filter out undesired components. It filters the noisy coefficients based on threshold value that can be data adaptive or non-data adaptive. An optimized threshold value is necessary for maximum SNR in the output image. A small threshold value won't remove noise. A large one will lead to smooth blurred image with no edge enhancement. There are three types of wavelet based filtering: discrete wavelet transform, dual tree real wavelet transform, dual tree complex wavelet transform. There are two types of thresholding: soft thresholding, adaptive thresholding. In soft thresholding, it is a tool that reduces background in an image. The intensity values below the threshold value are reduced to lower values. The background value is greater than 0.5, which is white, and the rest of an image is black. Coming to adaptive thresholding, as the name suggests, it is a threshold that is adjusted and selected automatically according to the image pixels and layout for converting the image pixels to grayscale. So we can see from the image, a denoised image is given to the two filters, that is low pass filter and high pass filter, which is being downsampled, and the low pass filter gives the processed image to the same filters, that is low pass and high pass, and the same process continues with the low pass filter. This is called forward wavelet transform, and the image goes through the forward and goes into the inverse wavelet transform where the image is denoised and the original image is found where noise is taken out or removed. So this is a good technique to remove noise. And we also have our proposed methodology, like when there is a noisy image, there are three techniques: discrete wavelet transform, dual tree real wavelet transform, dual tree complex wavelet transform. There are, with these three wave filtering techniques, we see decomposition into wavelet coefficients where the image is decomposed into wavelets and the threshold is estimated where it gives the required values that is needed for the image, and after that the inverse transform on the denoised coefficients is done where the image is denoised and it is given as an output, and the result is that the image is fully clear and does not have any disturbances. So with these three techniques, dual tree complex wavelet transform is more eligible and effective because from the input noisy image, the number of wavelet decomposition values are given, and estimate the noise and variance, and then calculate the forward dual tree complex wavelet transform. With these techniques, the complex wavelet transform is more efficient and gives out more effective and nice image. So we can see from the table we have taken 5 images, and from that images we see that the dual tree complex wavelet transform is more effective than other wavelet transform techniques. So to monitor the performance of wavelet transforms, the PSNR and RMSE are major parameters which show which technique is the best. From the observations we see that the PSNR and RMSE values of DTCWT are near to the proposed values, so it is more effective and more nice images. And we have also done on the brain MRI, which also shows that the dual tree complex wavelet transform values are more near to the proposed values. So we can see from the images where a noisy input is given, and we have done using all the 3 techniques, and we have found that complex wavelet transform technique is more eligible and more clear and has more detail to it. And so by this we conclude that the proposed work focuses on in-depth study of thresholding concepts and their importance in image denoising. The 3 major wavelet transform addressed as discrete wavelet transform, dual tree real wavelet transform, and dual tree complex wavelet transform. In DTCWT we have analyzed for both soft and adaptive thresholding. So the PSNR and RMSE values are also more to the DTCWT, and we have taken that technique because it has less shift variance and low directional selectivity. So we have only done up until the image denoising. So this approach also can be extended to video denoising with hybrid algorithms and adaptive thresholding mechanism in filtering the noise components. So we can see the percentage improvement of the filtering techniques, where in DTCWT the percentage of soft thresholding and adaptive thresholding is more compared to the DWT and DTRWT. So by this we can conclude that the image can be denoised with the filtering techniques, and we have done using the discrete complex wavelet transform. Thank you.